Hello, good morning. Today we are going to see the piezoelectric transducer. So we have just started the transducer chapter, and last time we saw the LVDT linear variable differential transformer, and now we are going to see the piezoelectric transducer. So piezoelectric transducer is nothing but crystal material is used in this transducer. So crystal is a material, okay, so it is some material called as Rochley salt, okay, and also there is another material that is tourmaline. So these two materials are crystal quartz, okay, so it is also known as quartz crystal, okay. So quartz crystal and this is the Rochley salt and tourmaline. These two material are having piezoelectric property, okay. So these two materials are having piezoelectric property. So what do you mean by piezoelectric? So here piezo is nothing but a pressure, okay. Piezo is nothing but a pressure, okay, and there is electric. That means it has, this material has this pressure and electric related something, there is a property, okay. So piezo means pressure and electric, so this property is related with the pressure and electricity. So suppose this is a crystal, it may be Rochley salt or a tourmaline. If we take a slice of that crystal, then it has a two axis, okay, just it has a two axis, and that is called as electric axis and it is a mechanical axis, okay. So this electrical axis and mechanical axis, these two are the axes, okay. So if we produce or if we provide a mechanical pressure on this axis of these two sides, then it produces a variable electric voltage on these two sides, okay. If we apply a variable pressure on this axis on the from these two sides, then it generates a variable voltage on these two plates or two sides, okay. And vice versa, if I apply a variable electric signal, okay, so say it is beyond 20 kilohertz, if we apply AC signal on this axis on the plate of these two sides, then it generates a mechanical vibrations on this mechanical axis on these two sides, okay. That means if you apply a variable AC signal, it generates a mechanical vibrations, and these vibrations are nothing but an ultrasonic waves, okay. So these vibrations are nothing but it is a ultrasonic waves, okay. So that means this is used to generate an ultrasonic waves, okay. So it is also called as ultrasonic waves generator, okay. So it can be used to generate ultrasonic waves, okay. So this is a piezoelectric property of this material. If we apply a mechanical pressure on this mechanical axis, it generates electrical signal changing voltage on this axis. So that's why such type of transducers are used like active transducer. Okay, it is active transducer. Okay, so this active transducer is used to measure a pressure, because this pressure is converted into the electrical signal, that is the voltage across this axis or across these two sides. Okay, so this mechanical signal pressure is converted into the electrical signal, and if we apply AC frequency beyond 20 kilohertz across this axis on these two plates, it generates ultrasonic waves. Okay, so this is a piezoelectric property, and which is used in the piezoelectric transducer. Okay, so let us see the construction of this this piezoelectric transducer. Okay, so this is a fixed base. Okay, so there is a fixed base. Okay, any insulating material based. Okay, then there is some support for this. Okay, or say there is some crystal. Okay, not support, we say some crystal is placed over the, okay, so this crystal slice is placed over the fixed base. Okay, which is placed over the fixed plate. Then to create a pressure, we put some material which is attached to a diaphragm. Okay, and this total structure is enclosed in a closed cabin. Okay, so this is a closed cabin, and there is a small opening. Okay, so there is a small opening, and which is for the provision for the air pressure. Okay, so here some material is fixed so that it can create a pressure on this crystal. So this one is the crystal. Okay, so this is connected to the movable diaphragm. So these are the spring actions. Okay, this is like a spring action, and this diaphragm is connected to this substance. It is used to create a pressure on this crystal. Okay, so this is the mechanical axis. If we can saw, this is the mechanical axis, and we keep the crystal like this on the mechanical axis. Okay, then some electrical contacts are used on the opposite sides. Okay, electrical contacts are made on the opposite sides, okay, of this crystal, and this is a electrical axis. On the electrical axis we made these contacts, and we get the output from the crystal. Okay, so this is a inlet, through that we create a pressure. Okay, through that we create a pressure. So from this side, if we create a pressure, it is nothing but air pressure. Okay, if we create a pressure, then this diaphragm bends down. Okay, this diaphragm bends down, and it creates a pressure on the crystal. It creates the pressure on the crystal. So as there is a pressure on the crystal, it generates a voltage, okay, between these 2 points to output. Okay, so this is nothing but a simple crystal transducer. So we are using a crystal which is having an piezoelectric property. What is piezoelectric property? If we apply a pressure on mechanical axis, it generates the voltage on electrical axis. If we apply electrical voltage on this electric axis, then it generates a vibration, that is ultrasonic waves. It can vibrate. So these sides can vibrate in and out, and it generates the ultrasonic waves. Okay, so such type of crystal is placed between the fixed base and some support to create a pressure on this crystal using the diaphragm. If there is air pressure, the diaphragm bends down and create a pressure over this, and it generates the voltage. Okay, so such type of another sensor we saw in a previous lecture, that is a capacitor transducer. So we know that capacitor transducer, okay, so let us show me that capacitor transducer we already studied there. Okay, so we know that so this is a capacitor transducer, we already studied about that. Same action here performed, but there is a crystal used here. Okay, sorry. Then it is just like, if you see this, the working of this transducer, it is just like a mic. What is the working of mic? If you speak in front of this mic, okay, suppose this is the mic, if we speak from this side, it generates the electrical signal, and that is connected to the amplifier, which it amplifies. Okay, but here this is a like a mic type action. If we create a pressure, that is nothing but sound pressure, and this pressure creates on a diaphragm which produces the pressure on this crystal, it generates this signal, and this signal is nothing but audio signal. Okay, so audio signal means if we amplify this and connect to the speaker, it generates a sound. Okay, so this is an construction of piezoelectric transducer. The pressure creates a diaphragm to be bent, and that bending of diaphragm creates the pressure. And this is a spring loaded, just like these are the corrugations that just like a provides a that is a spring action. If there is no pressure, that corrugation bring the diaphragm on the original position. Okay, if you press it, then it bend down, and if you release their pressure, then it, so this helps to bring the back the diaphragm to the original position. So this is a diaphragm. Okay, so this is a diaphragm. So this diaphragm brings back to its original position. Okay, so advantages and disadvantages. So this is very small. Okay, crystal size is very small, so this structure is very small, so we can use in a mobiles, on in a like a spy instruments. Okay, spy cameras to detect or to record a audio signal. So this is a very small in size. Okay, it is also a hard crystal, is hard, so it is stable for high temperature. Okay, so it has a large temperature range, but it has one disadvantage: it cannot measure a static pressure. Okay, static pressure cannot be measured by this transducer. Okay, so when there is a constant pressure from this side, then it cannot be detected by this signal because it requires a variable pressure. So this is the disadvantage of this crystal. It cannot measure static pressure. So you have to keep in mind that. But the capacitive transducer can measure static as well as dynamic pressure. Okay. So it is in application, we very well know that it is just used as a mic. It can be used as a mic in microphones, and it can be also used to convert mechanical pressure into the electrical signal, any type of. Okay, so this is the application. So in your book, so there is written the phonograph pickup cartridge. Okay, in phonograph pickup such type of crystal is used, but this is totally outdated. So just you have to remember that it is used in phonograph pickup cartridge. So in the last in old days there is a big disc, black disc, and which is placed on the rotating diaphragm, so that it can be converted that into audio signal. So such type of phonograph pickup cartridge used such a crystal. Okay, so the next one is a loudspeaker. Okay, so in our next chapter, next lecture, so we are going to see the loudspeaker. So I am making the small lectures because you don't have some get bored because of long lectures. Okay, so let us stop here.